You've probably turned a car around a corner without thinking twice about it. But have you ever wondered why the outside wheel doesn't drag or skid while you turn? If both rear wheels were locked together on a single solid rod, they'd be forced to spin at the exact same speed all the time. That works fine when you're driving straight. The problem starts the second you turn. When a car goes around a corner, the wheel on the outside of the turn has to travel a longer distance than the wheel on the inside. It's the same reason runners in the outer lanes of a track start ahead of the ones on the inside. If both wheels spin at the same speed, one of them has to slip, hop, or drag. That would wear out tires fast, stress the axle, and make handling terrible. More than 200 years ago, engineers solved this with a device that's still under almost every rear-wheel drive car today. It's called a differential, and this is how it works. What you're looking at is a complete rear differential axle assembly. The two long rods extending left and right are the axle shafts. Each one connects directly to a wheel. Their job is simple: take rotational power and deliver it to the tires. All the magic happens in the bulge at the center, often called the housing or the pumpkin. That's where the differential itself lives. Power from the engine doesn't come straight to the wheels. It travels down the length of the car through the propeller shaft, also called the drive shaft. That shaft spins into the back of this housing and ends in a small but very strong gear called the pinion gear. The pinion gear meshes with a much larger gear you can clearly see in the image. That big one is the ring gear or crown wheel. The pinion and ring gear do two critical things at once. First, they turn the direction of power by 90 degrees. The drive shaft is spinning front to back, but the wheels need to spin side to side. These gears redirect that energy. Second, they multiply torque. The small pinion turns the big ring gear, just like using a small front sprocket and big rear sprocket on a bicycle to make pedaling easier. You get less speed but a lot more twisting force, which is exactly what you need to move a heavy car from a stop. Now, bolted to the back of that ring gear is the entire differential case, and this is where the real problem solving happens. Inside the case, you'll usually find a set of small gears called spider gears or pinion mate gears. These spider gears are mounted on a pin so they can spin freely. They mesh with two larger side gears, and each side gear is splined directly to one of the axle shafts. Here's what happens when you drive. When the car goes straight, the drive shaft turns the pinion turns the ring gear, and the whole differential case rotates as one solid unit. In that situation, the spider gears don't rotate on their own axis at all. They just push both side gears around at the same speed, so both wheels turn equally, and the car moves straight ahead with full power to both tires. The differential earns its name when you turn. Let's say you're making a right turn. Your left wheel now needs to cover more ground, so it needs to spin faster than the right wheel. As the differential case rotates, the spider gears now do two motions at once. They're still orbiting around with the case, but they also start spinning on their own pins. By spinning, they allow one side gear to rotate faster than the differential case while they force the other side gear to rotate slower. The total average speed stays the same, but the power is split. The outside wheel speeds up, the inside wheel slows down, and the car flows through the corner without tire scrub or stress on the axle. It's a pure mechanical solution, no electronics needed, and it happens instantly and smoothly every time you turn the steering wheel. This standard setup is called an open differential, and it's what most passenger cars use because it's simple, quiet, and reliable. But it has one weakness. An open differential always sends power to the wheel with the least resistance. If one wheel is on ice or lifted in the air, all the engine power will go to that spinning wheel while the wheel with grip gets nothing. That's why you can get stuck even if only one wheel loses traction. To fix that, engineers created other types A limited-slip differential uses clutch packs or gears to resist large speed differences between wheels, so some torque still goes to the wheel with grip. A locking differential can be engaged manually or automatically to lock both axle shafts together, forcing them to turn at the same speed. That's perfect for off-road trucks and serious 4x4s where traction is unpredictable. Modern performance cars often use electronic differentials that use sensors and computers to shift power side to side in milliseconds for better cornering. Even with all these variations, the basic principle remains the same. The differential lets wheels rotate at different speeds while still delivering engine power to both of them. Without it, every turn would fight the car. Tires would wear out in weeks, axles would snap under stress, and handling would be a nightmare. It's one of those invisible pieces of engineering that makes modern driving feel effortless. So next time you take a smooth turn, remember there's a small set of gears in the middle of your axle doing a complex balancing act, just to keep your ride stable. It's not flashy, but it's one of the most important reasons cars can drive the way they do today.